Hey guys, welcome to day 7 notes. Happy Friday as well. Okay, so I basically just wanted to make a short little video to go over some of the main ideas that this angles unit really takes a look at. Okay, and please review some of my unit notes that I've already posted. Keep up with that little mini assignment, and then on Monday we'll do a whole section online, so you might do like a little quiz or something, or I think it's a bigger quiz because we're also going to do it on the previous day's work, so on like perimeter area, surface area, that kind of stuff, and we'll just put them together. Okay, alright, so here we go. There's a couple of angle theorems, and this is the more fun type unit. I guess that's what my students always say on angles, okay, an angle relationship. So angles that make up a straight line we call SAT, okay? So it's SAT because we know all straight angles add up to 180. So quite simply, if I wanted to figure out what equals 180, I would just add together the angles I'm given. So I have my obtuse angle, which is 120 degrees, and I most likely have an acute angle there. Then I need to figure out what that value will be. So I'm going to bring 120 to the right side. And remember, when it crosses over that bridge, like we've done in algebra, it's a good idea to review algebraic skills because there is some algebra in this unit. We would do 180 minus 120, and then x equals 60 degrees. Okay, now remember, it's a straight line that can add up to 180. So in the event where you have a straight line but there's multiple line segments, you know that collectively they add up to 180. Okay, alright, so our second basic angle relationship is a 90-degree angle, as we know from doing the Pythagorean theorem, does add up to 90 degrees. So what I have here is I'm going to have my x angle added to 65 degrees. I know that equals 90 degrees. So we'll bring over 65, and x should equal 25 degrees. Okay? And you could do that even in the II example down below. So again, just considering multiple parts, that could be also add up to a sum of 90. Okay, and last but not least, we have our opposite angle theorem, which is OAT in short form, angles that are across from each other at a point of intersection. Okay, so when you see intersecting lines, so this one's very straightforward. So if we see here, we have 160 degrees. If we actually had to find out what happened on the other side or what that angle may be, it would be 160 as well. Okay. Yeah, so I'll get you to do some of these. I'm just trying to see which one looks a little tricky. I think we could probably go over the algebra one. That one looks a little tricky. Okay, so we do see that this is a straight line. Okay, so that does in total equal 180 degrees. So I'm just going to do my work here, so I have a little bit more room. Okay, so 2x plus 25 is our first angle, right here. Okay, I'm going to add that to my second angle, which is x plus 15, and then add it to my third angle, which is x. And together, excuse me, that should equal 180. So because I'm adding polynomials, I'm going to drop my brackets, and because it's adding, it's going to be very straightforward. So I'm just going to collect like terms. So 2x, x, x, so in total that should be 4x. Okay, and then I'm going to add up 25, 15, which should be plus 40. I'm going to bring 40 to the other side. Remember, once it crosses over that equal sign, I'm going to have 180 minus 40. 4x equals 140. and then divide both sides by 4. X should be equal to 35 degrees. Okay, so then if I want to find out the 3 angles, I got to use that knowledge. So X is equal to 35 degrees. Here it's going to be 35 plus 15. So this angle is going to be equal to 50. And then for a third angle, I'm kind of running out of room, but I'll go up here. So 2 times 35 plus 25, that should equal 90 degrees. Okay, and you can even do a check. 90 plus 50 plus 35, is equal to 175. Oh, you know what? This should have been 95. My apologies. There we go. Okay, so that's why it's always good to check your work. So we got 95 plus 50 plus 35. Make sure that equals 180. It does. You're good to go. Okay. All right, so that's our first lesson, just learning about basic angle relationships. I'm going to move on to our next one. Please try some of these questions here. These ones are a little bit more, I guess they require more thinking in terms of your angle theorems, okay? All right, interior angles of triangles. So as we know, all interior angles of a triangle add up to 180. Okay, so the 3 angles in a triangle add up to 180 degrees. All exterior angles in a triangle add up to 360. Okay, so that means here plus here plus here, exterior means on the outside, they all add up to 360 degrees. And there's a couple of diagrams you can read here on the own that basically supplement why or where it comes from. Okay, there are 3 types of triangles that you should consider. Okay, the first being an isosceles triangle. Okay, so we know it's an isosceles triangle if you see these 2 markings. Okay, and isosceles means the sides and angles of the sides that are equal to each other will be identical. They will be the same. So automatically I can say, well, obviously x is equal to 30 degrees. Okay? Now to find y, I got to do a little bit more digging. So I'm going to take 180 degrees because I know that's my total. I'm going to subtract 30, and that means y is equal to 120 degrees. Okay? There's also an equilateral triangle. I'll go back to example 1 later. Okay, so with an equilateral triangle, if they're just the basic x's, we know 180 divided by 3 is going to be 60 degrees. Okay. Algebraically, though, how we can show it, x plus x plus x equals 180. When I add 3 x's together, I should get 3x, which is equal to 180, and then divide both sides by 3, get rid of the coefficient, so each angle in an equilateral triangle is always 60 degrees. Okay. This one is our scalene triangle. Okay, scalene means no sides are equal, no angles are equal. Okay, so here at its simplest form, if you're just missing angle x, we could just say x is equal to 180 minus 59 minus 36. And then find out that missing angle. Okay? So we see what happens for the interior. For the exterior, let's see. We can take this one here on the left. Let's do example 9. Okay. So for exterior angle theorem, remember the 3 exterior angles add up to 360. So I'm going to take 1, 2, 3 angles. So I got x plus 25 plus 85 plus x equals 360. Okay, and remember now it's not 180 because we're dealing with the outside angles. Okay, so once I add them all up, I'm going to collect my like terms. So I should have 2x plus 110 is equal to, oops, oh no. That's right, guys. There we go. Okay, is equal to 360. Okay, so then I'm going to take 110 rather, and I'll bring it to the other side. X is equal to 125. Okay, so then this obviously is 125, and then this will be 150. Okay, and if you add those three up, it does equal 160. Perfect. Okay, so that's pretty much those angle theorems. Okay, we can move on to quadrilaterals. Okay, so quadrilaterals, if you consider any type of shape, actually, we could get to the polygon formula. We know that triangles, interior angles add up to 180. Okay, we know a rectangle adds up to 360. A pentagon, so 1, 2, 3, 4, 5, you can see the pentagon has actually been split up in red into 3 triangles. Okay, and the idea is that if you take actually any polygon, and if we were in class, this would be an activity I'd love to do with you guys, you can split it up into mini triangles, ensuring that you're not actually intersecting other lines, and of course you're using a ruler so that you can actually see its full scheme. But something that you'll notice is our angle degrees for interior angles actually increase each time by 180, okay, depending on how many sides your polygon has. So you have a polygon formula, which is right here. So the sum of interior angles, okay, where n represents the number of sides. Okay, so obviously a triangle has 3 sides, rectangle 4, pentagon 5. Okay, so n minus 2 times 180. That will tell you how many sides, or sorry, the angles, sum of interior angles, that that particular polygon will add up to. Okay. So this is actually what I'm more interested in. Okay, so if you wanted to find the sum of a polygon with 5 sides, okay, so I would write my equation n minus 2 times 180. So 5 minus 2 times 180. So really that's going to be 3 times 180. So like we saw up above, a pentagon would have the sum of interior angles equaling 540 degrees. Okay. Now, we can further that if each polygon above was a regular polygon. So regular polygons have all the same sides and same equal angles. It's possible to have a pentagon, but that pentagon may not be a regular polygon because that pentagon might have different angles and different sides. So in this case, what you would do is we would take your sum of interior angles, so in this case 540 degrees, and just divide by how many sides that polygon has. And then that will tell me what each angle would actually be. Okay? So each angle. Alright? Neat. Okay. Yep. Yeah. Okay, so that pretty much takes care of this first little bit. Okay. There are also some line theorems. Okay, so I know I do go over that in that sheet that I posted online already. Okay, so let me know if you need any further supports in that. I can actually just pull it up so it could be on the video. If you just give me 1 second. Here we go. Okay, so this actually is a note that I posted 7 a.m. Okay, and it has like some of the stuff that we already talked about, but more importantly, it has like our angle properties that we've discussed here, and actually trickier examples. Okay, so again, I want you to take a look at them. Again, these are things that we've already discussed. The one thing I didn't discuss yet, though, is this. So maybe I'll just take some time to do that so that we're all on the same page. Hopefully you guys enjoy your weekend as well, eh? I know that you've been working really hard, and remedial classes are tough because they're so jam-packed, as I mentioned from the beginning. So you probably feel like you're doing tons and tons of math compared to what you're doing in distance learning, but I promise you it is almost done, and all your efforts will be rewarded, okay? As long as there have been good efforts. So, parallel lines. So when a transversal crosses parallel lines, okay, so the transversal is the line that goes through the lines that are parallel. Okay, so I'll highlight our parallel lines in pink. And our transversal is obviously our green line that goes through them. There are 3 classifications of angles that are created aside from opposite angle and supplementary. Okay, so there is our Z pattern, which is alternate angles. Okay, so with Z pattern, this means that angle E and angle D are equal because I can create a Z, and what's inside of those angles are actually equal. Okay, now Z's can also work backwards. So for instance, I can go this way. Reset, thank you. There we go. Okay, backwards Z. Here we go. There we go. Okay, so then these angles will also be equal, as you can see in your diagram. The same thing happens for F pattern, which is our corresponding angles. Okay, so you can see, oops, all right. So we can make 2 F's, one that looks like a regular capital F, or one that looks like a reflected along the y-axis F. And you'll see that what's underneath those arms are going to be what's equal to each other. Okay. The third being C pattern. So C pattern is a little bit different because C pattern actually adds up to 180 degrees. So with C pattern, we're going to create little c's, and together those angles add up to 180 degrees. Okay, and again, you can do the C the other way as well. So as you can see, sometimes there's some algebra that is involved. So for instance, let's just hone in and take an example F. Okay, so you can see that there's a creation of an F there in blue, and that means that due to our F pattern, which is our corresponding angles theorem, they are equal to each other. So you can see they are set on both sides. We're then going to bring all x's, or one of the x's at least, to the other side to collect like terms. So you see that 4x is now a negative 4x. That positive 20 on the left is now a negative 20. You collect like terms. You divide by negative 1 because you need to isolate for positive x, not negative x. And then once you get x by itself, you can actually sub it in. So this is like 3 times 30 plus 20, and then that would be like 4 times 30 minus 10. Okay, so there is algebra that can be used to solve for these different types of problems. Okay, I know the Pythagorean theorem was actually also discussed in the last lesson. Okay, However, I just wanted to make sure that we're all on the same page here. The one thing I wanted to make sure as well is that you're all aware that your hypotenuse is your longest side, and in that event you would use this formula if you're trying to isolate and find c squared, or c rather. Okay. The other two versions, if you are looking for a leg, and a leg, remember, are the sides that aren't the hypotenuse. You can isolate for a by moving b squared to the left side, so that would be c squared minus b squared. Or, if you wanted to isolate for b squared, that would just be c squared minus a squared. Okay? So when you're looking for a leg, you have to use a different formula. You cannot still use the regular Pythagorean theorem unless you are willing to move terms around once you apply them into the formula. Then that's okay. Alright? So again, here are some examples of when you're looking for your hypotenuse. So you can see we are doing a squared plus b squared equals c squared. Okay? We can see how that changes when we're now looking for a leg. Okay? So again, you can start with putting it with as a squared plus b squared equals c squared, but then you need to rearrange your terms so that one of your legs is isolated. If you get a negative answer using the Pythagorean theorem, you did something incorrectly in terms of how you should be laying out your equation. It will always be hypotenuse minus the other leg. Okay? So just be aware of that. You can't take the square root of a negative number. And those are just some application problems to challenge you, and some other questions as well. Okay, so please practice. On Monday we will have a more thorough quiz, because we didn't have one today. I really just want you guys to focus this weekend. If you have any outstanding assignments, you're going to do them this weekend. Okay, if you want the grades for them, it needs to be completed now. However, I'm looking at your grades right now, and majority of you are in a good position where you've been up to speed and up to date with most of your assignments. Okay, so for some of you, you might need to just take a look on Edsby as well. Your notes are posted, and not your notes, sorry, your grades are posted, so you actually are aware of what you're missing. So if you see a 0 or no mark, it's probably because you did not post something, but you can also check yourself. Okay, so I can actually view a student right now, and what you can do is you can go into your course tools. If you look at submissions, now I know there's a couple assignments where you see, like, for instance, U3A1, U3A4, that kind of stuff. So for some of them, they're module assignments, but the ones that are actually written out in full words, so for example, Unit 3 scatter plot assignment, if it says not submitted, it's probably because you didn't submit it. Okay? Day 6 assignment, so that kind of stuff. Also, if you want to take a look at your quizzes, okay, so you can click on your quizzes, and you can see at the very bottom of that is pretty much the quizzes that I've been using. There's a couple quizzes, U1, A5, U1, A7, U1, A9, U2, A5 that were kind of optional, and I really didn't count those. But the ones, again, that are written in full words, like on day 1 material, on day 2 material,